Arvin, and this is section 6.2 of Algebra 1, all about linear functions. For our lesson opener, let's go ahead and simplify these terms using our order of operations and reduce all fractional answers to lowest terms. So if we have negative 3 plus 5 divided by 4 minus 10, that's 2 divided by negative 6. And if we simplify that, those can both be divided by 2, and our lowest terms there is negative 1/3. What about 7 plus 4 divided by negative 3 minus negative 9? Well, 7 plus 4 is 11, and negative 3 minus negative 9, so add the opposite of negative 9. You get negative 3 plus 9, that's 6. We get 11 divided by 6, and that cannot be reduced anymore, so that is the lowest terms. How would you simplify these? 6 minus 2 is 4, and 40 minus 12 is 28, and that can be simplified down to 1/7. What about negative 1 minus 5? Don't forget with these negatives, you're already left here. You're left 1, and you want to go left 5 more, so that's negative 6 on top. And 3 minus negative 12, so that's adding the opposite of negative 12. So you got negative 6 on the top and 15 on the bottom. That does reduce to negative 2/5. Okay, our biblical integration is this. God provided 4 different gospel accounts in his holy word, Matthew, Mark, Luke, and John, that provide us different insights into the same story, the life of Christ. Graphing equations, it helps us to see written information from a different perspective. I could give you a chart that shows you the relationship between a lot of different things. The relationship between the amount of time you sleep and your grades, or the relationship between the amount of time of study and your grades, or the relationship between height and weight. And charts are great and wonderful, but it's on numbers. What graphing equations does, it allows us to see that same information, but in a visual form from a different perspective, which is always helpful. Our lesson objective for today is that you, the student, will find the slope of a graphed line. You'll find the slope of a line passing through 2 given points. So the first thing that we need to do is talk about what slope is. You got to know what slope is before you can find it. The slope of a line, which is represented with the letter M, is the ratio of the rise, the vertical change, to the corresponding run, horizontal change. So we want to know how much the line changes vertically and write a ratio with how much it changes horizontally. So we call that rise over run or slope. Slope is really just how much it changes from one point to another. It describes the incline or the steepness of the line. So we could have, if you think about it, a road that has a very small slope, it's just it gradually increases or gradual incline. But maybe you've gone up a roller coaster that has a very steep slope, okay, a very sharp incline. It changes very quickly. So slope just tells us how much something changes from one point to another. In order to find slope, we need 2 points, so we know how much the line changes from one point to another. So we would use 2 points on a line to find our slope. So let's take these points. We know that our line passes through 3, 1 and 5, 4. So if I were to graph these, which you do not have to do, but I just want to show you where these would be, and 5, 4, okay, just roughly, that would be these 2 points. And I want to know how much it changes. What's our rate of increase from this point to this point? It looks pretty steep there. Well, in order to find slope, we know our rise, or the change in our y values, is 4 minus 1. We went from 1 to 4, so we had an increase of 3. And the change of our x values, our run, we went from 3 to 5, so that was a change of 2. Our slope is a ratio of these 2 numbers, rise over run, or 3/2. So our slope is 3/2. How would we find the slope? By counting. Well, we would pick convenient points, maybe here and here. We would count the rise. So our rise was 1. We went down 1, so that's a negative 1. And then we would count our run, which is a positive 2. And then we would write it in ratio form, which is negative 1/2. That would be our slope. This little symbol here, delta, it's a triangle. It's a Greek letter delta. It just means change. So our change in x, or change in y. Our change in y was negative 1. We went down 1. and our change in 2 from left to right was positive 2. And as a slope, there we said m is equal to negative 1/2. So a downward slope and kind of gradual. Hey, here's how we would find slope using a slope formula. So we choose our points, -1 and 3, and 1 and 2. We find the rise, which is the change in y, and we find the run, which is the change in x. In the formula, that's what this looks like. It's going to be y minus y, and our x minus our x. So we took this y minus this y, so our first y minus our second y, and then we took our first x minus our second x. When we do that, we get 1 over -2, which is -1/2. So we get the same information. There is the general formula for the slope between two arbitrary points, represented with x1, y1, and x2, y2. And this is the formula that I just wrote on the previous slide. In order to find our rise, or a change in y, we take our second y minus our first y. And in order to find the run, or a change in x, we take our second x minus our first x. So let's do an example together. Find the slope of the line passing through 2, -3, and 4, 1. The first thing we're going to do is write our formula. It's always helpful to write your formula every single time so that when you make substitutions, you don't make any mistakes. Right? Then I'm going to label this x1 and y1. So my first x and y, and then my second x and y. I'll then go ahead and substitute those into our equation. So y2, I'm going to use 1, and y1 is -3. Notice I am using parentheses here to protect my negative with that -3. My x2 was 4, and my x1 was 2, so 4 minus 2. Then we go ahead and simplify that. 1 minus -3 is 4, 4 minus 2 is 2, and when we simplify again, 4 divided by 2 is just 2. So our slope in that equation for that line was actually 2. The slope is the same regardless of which point is considered as the first. So I could have said this was my x1 and y1, and this was my x2 and y2. Or the other way around. It doesn't matter as long as your x2 and y2 are the same coordinates or in the same parentheses, and your x1 and y1 are in the same parentheses. Here's the same problem worked out, but with the x's and the y's swapped as to which one's first. So -3 minus 1 over 2 minus 4, we get -4 over -2, which is just 2. So it really doesn't matter which one you label as 1 and 2, as long as your 1 and 2, x1 and x1 and y1 are in the same set of parentheses. So when finding the slope of a line, first we want to determine the rise and run from one point to another point on the line. Remember, rise is just how much it changes vertically, so it's the change in your y values, and run is how much it changes horizontally, or the change in your x values. We then want to write the ratio of rise over run and reduce if possible. And we can write the ratio just by looking at the graph or using our formula to help us write that ratio. Let's find the slope of a horizontal line y equals 4 using the points 2, 4, and 7, 4. So we've got this horizontal line y equals 4. Well, just by looking at it, you should be able to determine the slope. How much does it change? It doesn't. It doesn't go up. It doesn't go down. It has 0 change. Let's see if our slope is in fact 0. So using our formula here, y2 minus y1, x2 minus x1. So x1, y1, x2, y2. Go ahead and label those and then substitute in. So we get 4 minus 4 and 7 minus 2. That's 0 over 5. And 0 divided by 5 is in fact 0. The slope of a horizontal line is always 0 because it doesn't change. Remember, slope is a rate of change, and a horizontal line doesn't go up or down. It doesn't change. Let's find the slope of this vertical line, x equals 3, using these points. If you look at that, that's a pretty steep slope. Okay, but how would we write that? Well, let's use our formula here. y2 minus y1, x2 minus x1. We're going to plug in these points. This is our x1, this is our y1. We forgot to label them. x2, y2. plug those in, and when we plug it in and do the math, we get 6 divided by 0. If you remember what we said earlier, can you ever divide something into 0 groups? Nope, the smallest number that you can have is 1. Even if you have, if you've got a bunch of flowers and you want to divide it, the smallest group that you can ever make with that bunch of flowers is 1. You can never have 0 of that bunch. Your flowers just wouldn't exist. So if you have a bunch, the smallest thing you can divide it into is 1. You can't divide it by 0. And we have said this earlier, but just in case you forgot, anything divided by 0 is undefined. The slope of a vertical line is always going to be undefined because it's going to have no horizontal change. Let's try graphing the line passing through this point with this slope. The first thing that we're going to do is graph the point -1, 2. Oh, let's put that on the graph, -1, 2. Then we're going to use our rise, which is our vertical change, over our run to plot the point. And what that tells me is that I need to assign that negative sign either here or here, one or the other. I'm going to assign it to the 1. So I'm going to go down 1, and then to the right 3, positive 3. 1, 2, 3. So down 1 and to the right 3. The other way I could have graphed that was I could have gone up 1 and then to the left 3. Boom, boom, boom. That's right here. If you see, if I connect those points, you do make a nice straight line here. We're going to finish what I just said. We can use -1, 3 or 1, -3. Draw a line through the points. And that is our line there. The sign of the slope indicates whether the line slants up or down, moving from left to right. And the absolute value of the slope indicates how steep that slope is. All right, I'm going to give you a little memory trick here. This little guy is on my wall, but this is Mr. Slope Face. A positive slope goes this way, uphill. A negative slope goes downhill from left to right. Slope equals 0, that's a horizontal line. And when slope is undefined, we know that's a vertical line. Okay. On my wall, I have a picture of a thing that we call Mr. Slope Face, and you'll see he looks like a smiley face, but it actually represents the different slopes. He's got a line going uphill with a little plus sign here to remind you that that's positive. He's got a line going downhill with a little line here to show you that that's negative. He's got a straight mouth with little zeros on the end to remind you that a straight line has 0 slope. And then at the bottom of his nose, he's got a U to remind you that a straight up and down line is undefined. So you guys can see that on the wall when you come in. There are several different ways that you can see slope. You might see slope written as M. You might see slope written as rise over run. You might see slope written as y2 minus y1 or over x2 minus y1. Or you might see it as delta y over delta x, which means the change in y over the change in x. Okay, we've already talked about this already, but there's the Greek letter delta, and it's used to symbolize a change in something. Remember, the slope is a rate of change. Rates of change compare two different things that are changing, two different quantities, in this case, x and y. So today, we found the slope of a graph line, and we found the slope of a line passing through two given points. We will do some more practice problems in class. Make sure, though, if you have specific questions, that you go back and re-watch anything you're slightly confused about. Write down any questions that you still have after watching the video. And be sure to ask me next class.